Good afternoon, all. This is a Gottlieb System 80B with the daughter card, Diamond Lady MPU board, and it was sent to me, and the problem description is it does not boot. So that's, you might think that's a bit terse, but really that's all I need to get going on this. The main problem with Gottlieb MPU boards is they don't boot. And there are several reasons that could be, and we'll go through those one at a time. This particular MPU is very clean. I did have to retin the edges where the power comes in, and I sanded these. This is a switch matrix from the playfield. This is a switch matrix from the cabinet. I'll sand those a little bit more, dress them up, and then I'll retin those edges also. Somebody put a Frank's super battery holder, I'm not sure what that's called, or the equivalent, onto this CPU board. I like these. I think they're, for me, being a cheap ass, I think they're kind of overkill, but they're good for most people. So the approach is going to be, number one is replace this daughter card. These things, they were designed so that they're sort of cantilevered from the socket position, and this whole section over here is floating out here. Gottlieb put 3 rubber bumpers underneath there to try to prevent some of the vibration, etc. Or when you're putting a ROM chip in there, this is going to stress out the blind joints that are on the back side of this card. And I used to use Ed's alternate daughter card that he made with Great Plains Electronics, but Ed is dropped out of the picture, unfortunately. Would love to get him back into pinball, so I started making my own, and this is the single U3 version of the same thing. Now this had a 7404 on it. Being a cheap ass, I don't like to use a whole 7404 when it needs only 2 gates, one in, one out. So I use these super tiny single gate inverters, and then here's a bypass capacitor that I added to the back of the board that's between 5 volts and ground. And I'll remove this card cleanly. I'll put a machine pin socket in there, since these have machine pins that it's going into, and then we'll see if it boots. So let me get rid of that daughter card. Maybe I can show you how to do this. The first thing you do is, these pins are awfully long, so we want to bring the smallest amount of pin through those holes as possible. Now sometimes when you cut these, it leaves a little edge on it, so yeah, this is a good sharp pair of side cutters, so let's go ahead and do that. Let's just cut some of these pins off here. Easier to do one at a time, apparently. Where these things are landing, nobody knows. Well, we've got all these off. We are going to use a technique that I talked about with a friend of mine on the West Coast, pinsider named Cheddar. And we talked about using low temperature solder, or low melt solder, or chip quick, and that's what I'm going to do here. I'm just going to glob some chip quick across this joint. Now most people don't have this big old tip that I've got. You can do this without this big tip. This just makes it a lot easier. So I'm going to make sure there's chip quick on all of those pins. And first mistake I made was not getting some flux on there. Even though you're using chip quick, it's best to use some flux. So get the right iron tip out of here and reflow that. See how easily that flows with the flux added to it. And I'm just going to quickly go from side to side I pulled one side out just now, and there's the other side. So while it's still hot, I'm going to kind of reflow all that. Let's take a look at the other side. Yeah, it looks clean. Now I always let this stuff harden up again before I use my Hako to get rid of it. This daughter card actually looks pretty good, but there's no way of knowing that in advance because you can't see these joints, obviously. Some people will take this card off, reflow the joints, put it back on, but I think it's better to put a better manufactured card on there than this relative piece of junk here. I will take the 7404 off because nothing goes to waste, and of course we'll reuse the ROM. Now, my friend Jim Paulson, rest in peace, I really miss talking to him, but what he used to do, he used to tell me, he would take a nut driver. This is the wrong size, but imagine this is the right size to fit just in between there. And he would leave this board on. He would put that nut driver on there and then whack the end of that with a hammer, and this thing, this card would drive down through these solder joints, through these legs, and then you'd be able to pull it right off. Now, I wonder if he was pulling my leg, and unfortunately I'll never know the real answer to that, but I don't think I'd try that. If you guys knew Jim, and you know for a fact that he did in fact do that, let me know. I've cleaned up those holes, and I have used a fiberglass pencil to scratch between these and eliminate any detritus, solder detritus that might exist there. And then I looked at these holes under extreme magnification to make sure there's no solder bridges between, say, this trace and this hole or that hole. And we're good to go. Now, like I said, we're going to put a machine pin socket in there like this. I don't like these normally, but if you're putting a machine pin device onto a board, then you use a machine pin socket. So I always use a machine pin socket for the 5101 or Z5 because a lot of people put VRAM in there, and they all have machine pin sockets. So we're going to insert the socket, notch up, I'll hold it on the other side. I've got an appropriately sized solder tip for this job. The little blob of chip quick there, I'll get that off later. And tack down a couple corners, a couple more corners. Good to go there. And then how you orient the board is to your own preference, but this is the way I do it, is melt the solder on the joint and then lift the iron smartly off of that joint. So you're forming a solder volcano, also known as the solder meniscus. And you don't really need a lot of solder. Like some people on WPC power driver boards think they gotta put this gigantic amount of solder there. You don't. Let me see if I can get that solder blob off of there. Should come off. There it is. Get rid of that. Untold hours of debugging could have been required. All right, now I've got this handy dandy dispenser of, what do I use here? You can use rubbing alcohol. What do I use? I can't think of it now. Naphtha is the same. And we just clean up that joint. Machine pin legs are really easy to clean up. Your Q-tip doesn't get hung up on there. What is that stuff? All right, so now we are ready to install our new daughter card. Notch up. press down firmly. I like the way that snaps into place. We'll get our ROM out of the old socket. That baby's in there. And before I install that in here, the ROM back in, I'm going to connect this board up to my QuickScan 80 and see what it's telling me. While I was working on it, I did see that there's some corrosion on these 3 resistors that are in the clock circuit. So this is the crystal, and it uses a 7404 and a 7474 to clean up that clock signal a little bit before it goes to pin 39 of the processor via this jumper E2. So I need to do that anyway. Why don't I just clean that up? As I was looking at that, I realized I needed to take Frank's battery board off of the board to check for corrosion beneath it, and sure enough, the positive trace is quite corroded. Let's see if there's any underneath the crystal. No, none there, but I still need to clean up these traces and at least these 3 components. I may scrape the whole reset section and use a modern reset generator. Well, the more I got into this, the more corrosion I identified, and so I scraped the parts on the other side of the board, and I'm in the process of removing the remaining legs for the parts. So this was the crystal. I decided to take the crystal off, and the 74 below it. But this is the leg of a 5.6K resistor, I think. You just heat the hole, lift it out with something that's good enough to grab it, and this minimizes the damage to the through holes. While you're doing this, I always end up flipping this around so I can get my left hand operating the side cutters. I'm not cutting, I'm just using these like tweezers to pull those parts out. And then we'll come back with our Haco and then clean up these holes. Here's where I saw the additional corrosion. In addition to here, there's some leading to pin 1 of Z2, and Z2 was corroded also. So would that have been okay to leave? Yeah, probably. Am I going to leave it? No, gotta go. Here's where it gets a little nasty. You can sand all this stuff up, but just to expedite the process, I use a sharp flat blade screwdriver to clean off that solder mask. This is a critical via, as is this one. They go over here somewhere. And once I get the solder mask off, that I'm mostly concerned about, then I've got this 12-pin Molex connector that came off of a System 11 machine, and I use it as a sanding block. And just go to town. This glue, adhesive, whatever they had, holding that clock or the crystal down, always gets in the way. Sometimes you just can't get down into the trace with the sanding block, so especially on these fatter traces. Sorry about that, I'm shaking the whole table here. I'll just sand them like this. Funny, I was watching another YouTuber, Blondie Hacks. She's a machine shop hobbyist, and she has got a new machine, and she put it on a table, and it was shaking just like this. All right, you get to the point here. I'm gonna clean up the rest of this and install some jumpers. I'll be right back. So I've got a pile of old resistor legs that I save just for this kind of purpose, and various bending tools, so I can make all the jumpers necessary to install the Dallas Max. That one I just bent around the tip of those needle nose pliers, but I've got this handy bending tool for components. You just bend it across there, and then you can insert where it goes. So that's two of them thus far. The Dallas chip, grab one. Goes right here, since I've done this a million times. And I've got to put the 3 resistors in here, new crystal. I've got some jumpers to add, one from here to here and one from here to here, and put a cap back on there. And then once I do that, then I can conformal coat this area and then install the socket. You can see there's a bare copper there. I could tin that, but it's just a lot easier to, if you get your order of operations down correctly, to install what you can, conformal coat, install the rest. So I finished adding all the jumpers required. I put these 3 resistors back in. The blue one is a 1% resistor versus the 5% resistors. This is 2K, 2K, and 5.6K. It doesn't matter what you put on there as long as it's at least as good as the original spec. And I just buy these 1% resistors because they're cheaper than the 5% resistors sometimes. So we've got a jumper here, 1, 2 jumpers, 3, 4. And here's the DS1811. It's actually a, I forgot who makes that part, but it's not a Dallas Maxim part. It's the equivalent of that. And so this board is good to go except for conformal coat. I'm going to clean it, then I'm going to conformal coat it, and then I'm going to install that socket, and then we start another chapter. Here's the diagram that's in the pin wiki, and I use this all the time. It's originated with the Great Plains Electronics, I guess, CAD drawing of the System 80 MPU, and then between Paulson and myself, we updated it to show all the jumpers in red where the DS1811 goes. There's the note. And then labeling the components that remain and coloring them in yellow. This is incredibly useful because unless you've done this 100 times like I have, what are those parts? I don't know. And especially this 0.1, 3K, and 0.01, I still have to look at the diagram to see what the ordering of those are. We leave the 41 and 48 and the 62 ohm resistor so that the battery that we are going to place on here depletes at a normal rate for the 5101, and the battery doesn't power the whole board. That's it. I got to put a 100 microfarad cap on there. I was just looking at that. So let's get to that, and then I'm going to wash this board up. So I have conformal coated the bare copper and installed a new crystal and these 2K, 2K, 5.6K, a new 7404, and maybe some other things since I last left you. But this, from this perspective, the CPU should be good to go. So I have it attached to the QuickScan 80, and I'm going to power on 3, 2, 1. And you can see the top 2 LEDs are left as this, indicating the clock is good. RQ is not good, and reset was good, and it's indicating a failure of U5, which is unusual. U5 controls the displays. Sometimes with these 6532s, you can put your 3 fingers on them and detect that one of them is hotter than the other, but I'm not getting that indication here now. So I'm going to believe the QuickScan 80 and take U5 out, install a socket, and we'll test it once we get it out and install a new one. So it was acetone that I used to clean solder flux off. So I've got this U5 out, got a nice socket in there. I like these ones that are They're not all open frame. They've got the cross member here. It makes them a little more rigid. So let's test this 6532 with the Neo Lock Inquisitor, and that is a dead 6532. Interesting. Now here's one from my supply, and that one's good, and that's why I've got it marked with the gold on there. So let me install that and we will see how much success we can have. Quick Scan 80 connected, and it looks like we are good to go, at least from the perspective of the Quick Scan 80. 4, 5, and 6 are the three 6532 RIOTs. 1 is the 5101 RAM. So the next thing to do is take it over to my System 80 bench and get off the top of my Spider-Man. And finally over to my test bench with the Diamond Lady MPU, and I did reinstall Frank's battery holder and one of my bench batteries. Can't ship lithium-ion batteries. Here's my bench driver board and driver board test equipment, and a Lizzie 80B display, which is quite spectacular. Booting, that is a normal boot. You'll notice the FP there, that is free play. We have erased the client's ROM and then reburned it with the McZonk on Pinside's version of the ROM, which incorporates free play. We are booted, and the CPU is driving the driver board to drive all these lamps. Let me do this. Let me put a credit on the game. Oh, actually it's on free play. What am I thinking? Oh, never mind. All right, let me get in a test. I'm gonna hop to lamp test by pressing the equivalent of the credit button on the coin door. That's good. Next test is solenoid test. Here you can see there's some lamp circuits that are used as pre-drivers to underplay field transistors, or mounted in the back box transistors, or mounted on the sidewall transistors that drive the big coils in Diamond Lady. I played a Diamond Lady at Expo one year. That's a fun game. Let's see. All right, next test is switch test. Oh, I delayed too long. Switch test. This is an important test. I'm going to go across the diagonal of the switch matrix. The switch matrix and lack of protection on System 80 boards is the kind of the Achilles heel. Of course, if you don't work on the game with power on under the playfield, then everything's fine. The dip switch is 0307039B, and that is correct. And the last test is display test. I always forget about this one because it's boring. I wish Gottlieb had sped this up. And then we have memory test. Good to go. So, thank you so much for sending this board. I shall remove the lithium-ion battery for shipping. We should be good to go.